The atomic number, the atomic mass, protons, neutrons, and electrons. If you have a tag, let me get a pen instead of a highlighter here. If you have a tag and you'll have a number at the top, be like 2 for helium, and then down here at the bottom, a lot of times this will be a decimal at the bottom, we're just going to round it. The atomic number is the number at the top, and of course that tells you the number of protons, as we said earlier. So if I got 2 positive charges, there's supposed to be little pluses there, that's the atomic number. The atomic mass right here is the total mass of the nucleus, or the number of protons and neutrons. The atomic number is the number of protons. The atomic mass is the number of protons and neutrons. All right. So the atomic number up here will always be the same as the number of protons, because that's what it means. So we have 13 protons there. Right here we got 20 protons, so the atomic number is 20. And then down here, we'll come back to this one. Again, down here we have 11 for the atomic number, so 11 protons. Okay. Now also, we have the electrons spinning around the outside, and these are negatively charged. And so for each positively charged thing you have in the nucleus, the atomic number, you also have to have the same amount of negatively charged things spinning around in this electron cloud out here. So as we see, hey, there's 11 protons there, there's 11 electrons there. There's 10 electrons here, so I know it must be equal to 10 protons, which is also the atomic number 10. These 3 numbers will always be the same. We got 37, we have 37 protons, so we have 37 electrons. We have 20 protons, so we're going to have 20 electrons. And we have 13 protons, so we have to have 13 electrons. Now the last one, neutrons, that's the only one you got to do some math. I always say Jimmy Neutron loves math. And what you're doing, you're going to take the atomic mass and subtract the atomic number. You're going to take the mass of the nucleus, which there's 4 things here, and you're going to subtract out the atomic number, which is the number of protons. So when you get rid of those, all it leaves is neutrons left behind. That's how this works. So you take 40 minus 20, well, that's going to be 20 again. All right, you take, let's see here, 85 minus 37, that's going to be 48 neutrons. If you take 23 minus 11, that's going to be 12. And for this last one, well, we're going to go backwards, whereas here we're taking like 23 minus 11 equals 12. Well, we're missing the atomic number. So we go backwards. We know the atomic mass is the number of protons and neutrons. So we see right here I have 10 protons and 10 neutrons. Well, the atomic mass should therefore be 20. You just add them together. You do the opposite. And the math still works out if we're doing 4, where we got 20 minus 10 would be, hey, 10, the number of protons. If the video didn't make sense, go back through it a few times. Go back through it a few times. It'll start to click in the more times you see it, the more repetition that you get.